Here we are again. It's Christmas calendar time. Monday, 8 o'clock in the evening, and we are going to see news and updates from idonotbelieve.com website. Intro, fast charge, high temperature, self-discharge, sneak peek, mule. Safety demonstration test. And DL2 is taking a comeback. This evaluates a cell's ability to operate safely after sustaining damage. So it got some hits. During our previous high temperature test, the pouch surrounding the cell lost its vacuum, a failure that would cause fire or thermal runaway in any conventional lithium-ion battery. I guess so. Even though there might be some examples where some special batteries can go to the same high temperatures and not necessarily get damage right away. At least not getting to the thermal runaway event. We took that same damage cells and cycled it through 5 1C cycles and 50 fast charge cycles at 5C. No temperature spikes, no fire risk in this skin area. The donut battery fails gracefully when damaged. So they are really confirming that the battery as a whole, it was damaged. Continuing to operate safely at reduced capacity rather than posing danger to the user. So even it was it lost the vacuum and it was damaged, then we already saw that it could do some recharge, or was it charge, in the first test, hot test. But now they are going through many more cycles to show that it really operates. Does it operate well or by reduced capacity? Okay, so it's not working 100%, but working and functioning anyway. Next result will go live in 8 days and 17 hours. So it will be Tuesday, it will be Wednesday. Is it 2 o'clock next Wednesday? 1st of April. I guess so. Let's see the video and then peek to the VTT report.
Hi guys, it's Marco from Donut Lab.
Hi.
You are watching our battery proof series called I Donut Believe. In this series we demonstrate the capabilities of Donut battery, which is the world's first solid-state battery used in production vehicles.
First in the world in production of vehicles. So they refer to it words motorcycles, I guess.
Today's topic is safety demonstration tests. When we released our high temperature test, we mentioned that the pouch had broken and lost its vacuum at the end of that test. These industry standard pouch materials are simply not designed for the 100 degrees Celsius that our batteries can take.
Okay, so in the last episode we took a deep dive to the regulations and so forth, and it got clear that at the moment the solid state battery business, all the regulations, specifications, certifications they are not ready yet. So this is quite a scheme at the moment. There are a lot of open things. So I think this refers to the same problematic situation, that not even the certifications, but also the material they used for solid state batteries, they are not made perfectly and specifically for the solid state batteries, but they borrow some components from earlier battery types.
A lot of you picked up on that, and many assumed the cell must have started decomposing or even gone into thermal runaway. So in order to demonstrate how safe our battery really is, we took that same damaged cell and just kept cycling it. Obviously, the cell is damaged, but even then it remains completely safe.
It's damaged but safe. So we know already that solid state batteries, they should not run to fire. They have different kind of physics and chemistry inside. So I think this is quite natural, I guess. But also, what is interesting now is that they are reacting to the community after 2 weeks. So this test was not planned originally. So they have 3 tests for fast charging, hot test, and self-discharge. And there was an accident in the second test, and this is of course it got a reaction in the community on the social media and everywhere, and this video and test is a reaction to that. Very interesting. They are going dialogue with the community here in a very special way.
Any lithium-ion battery in this condition would simply catch fire, while the donut battery just returns an error message. Let's go and watch the test.
Error message returns an error message. Possibly in the BMS battery management system, they can control every battery cell there and get some signals back to the main processes, and I guess you get some error messages there. But in VTT lab situation, what was the error message?
Thanks, Marko. This test was conducted by VTT, which is a government-owned technical research center of Finland. The full report made by VTT is available for download at idonotbelieve.com. So let's dive in. You might have noticed at the end of the previously released high temperature report that during the 100-degree test, the pouch surrounding these cells' active materials had lost its.
They even touched the cell, so there's some room for air there, or gases. And it's in VTT, of course, in Finland.
Its vacuum. This particular cell design uses pouch materials and adhesives borrowed from the lithium-ion industry, and as you can see, they are not designed to continuously operate at 100 degrees Celsius. If this kind of pouch failure happened to a conventional lithium-ion cell, the result would be catastrophic.
I remember just researching the regulations, EU regulations, and they had this special test in which they start from temperature minus 40 degrees Celsius, and then lift the temperature to 60 degrees Celsius, and then back to minus 40 degrees, and 5 times. So yes, there are some similarities over here, but they are not going down to the minus Celsius. And the upper limit they are using here, it was 80 degrees Celsius first, and then 100 degrees. So the regulations and practices also, not only the cover of the cell, the pouch, but also the regulations, they are not up to date to these kind of tests, I guess.
Lithium-ion cells cannot operate when the liquid electrolyte leaks out and active materials come into contact with oxygen. And even if a lithium-ion cell somehow survived the pouch failure without catching fire, the likelihood of it going into thermal runaway significantly grows the moment you start charging and discharging it again. To prove that the donut battery continues to operate safely even in this state, we took that very same cell with the broken pouch and started cycling it. To be clear, these are not normal working conditions for any cell, and this is not a life cycle test. This is a test to prove that the cell simply does not catch fire even when cycled with a broken pouch, something that conventional lithium-ion cells simply cannot do. Now let's
So they are restating the same thing, that these are not lithium-ion NMC batteries. So they are solid-state batteries. That's what they claim, and they try the last 3 episodes by them. They have repeated the same mantra. But it's interesting that they cannot demonstrate straightly and straightforward way what is the type, what is the chemistry, but they use this indirect way, try to convince people that by putting these batteries on these conditions and doing these lab tests, you should be able to conclude that these are solid-state batteries. I'm not totally sure why this is important at all, unless this is only a marketing tactic. Because for the skeptics, real skeptics, or the high skeptics, this will never get them convinced. And they are leaving out so many details from these tests, so it's a little bit contradictory way to try to convince people, but that's what they do, and the marketing side of the campaign, it seems to work well. And of course, it's really interesting to try to find out the way to secure the position about the chemistry, even with the limited information.
Let's jump into the report and see what happened. The test started with 5 standard 1C charge and discharge cycles. And as we can see, even with the broken pouch, everything looks completely normal and the battery is operating as it should. Then the cell was fast charged at 5C rate for 50 cycles. Here we can see how the cell keeps working in a safe manner even though the capacity starts to drop early in these cycles. The capacity stabilizes to around 11 amp hours, and in the final 5 1C cycles it actually even regains some of the capacity. The cell continues to operate safely with no spikes in temperature and with no risk of catching fire, even after being clearly damaged, having increased in thickness by around 20% and losing half of its capacity. What this means in real-world use is significant. In this type of a failure mode, the donut battery fails gracefully with no harm to the user, and demonstrating it handles this sort of a scenario far better than conventional lithium-ion batteries.
Okay, maybe that's a point. Of course, you could have done many other damage and safety demonstrations, like drilling a hole to the battery and so forth. But this was kind of improvising with the DL2 battery, I suppose. Very interesting, of course.
That is all for today. Thank you for watching, and the full report is available for downloading at idonotbelieve.com. See you next time.
Let's take a quick look to the report. If there is anything interesting that pops out from it. Version. So this is 10 days ago. Project customer. Nordic Nano Group is not mentioned this time. That's interesting. Let's see how about the other. Here we have it. How about here? In the second we have Nordic Nano, and the first there's also Nordic Nano. For some reason in this report they don't have that company mentioned. And now times, it's always interesting to see these small details here about the timestamps. So this was signed by Petri Söderena and 16. So it was last Monday at around 9 o'clock. But they had this ready, but they decided to give us a Verge motorcycle sneak peek for some reason. Okay. And they do this test in 25 room temperature. Identify 3 visually identical cells. We know these. Continuous cycling. The test report herein. Yes. So here we see the setup for the test. There are heat sinks on both sides and temperature sensor attached to the folded seam on the side of the cell, and some white block and current cables. And then they do the cycling test. There's a start, initial position, and then there are reference cycles 1 to 5. Then there's a cycle 6. This is also, this is 1C, and then this is 5C current. It was a reference, and then there are 49 times cycles in 5C, and then there are still some reference cycles in 1C. Okay, and then we get the data tables. Okay, I need to use some time later for interpreting these graphs. But here is some drop on the capacity. It's interesting what happens to the battery after it got broken. The vacuum seal or something got it was damaged, and then they took it to the cycling tests. Oh, in the second test they also did some charge or discharge test once or something like that. But that didn't give really good idea was the battery really working. But here they continue with the cell, and it looks like it performs quite well, but then it drops in the 1, 2, 3, 4, 5, 6, 7, 8, 9, ninth cycle or something like that. Then the capacity drops quite much and keeps there. And they told that it a little bit, by a tiny bit, it improves. So it stabilizes. This is interesting feature of the cell. In our TGD group meeting, we briefly discussed that these type of cells, they are quite close to the biological systems. I don't know how close this actually is in reality, but there are some analogies you can find that the system can it can sort of recover from some damage and keep and operate at some level. And I remember also the very early protocells from a CT coating. They also had this feature that after a couple of hundred cycles, they got better. So there is some sort of stabilization that is a lot different from lithium-ion batteries, and this also kind of it tells the thing I've been thinking with cycle life and cycle tests. Because you cannot really know until you have made very, very extensive tests and worked with the chemistries and research it very closely. You cannot know if there is some focal points that change the chemistry and operations radically. Like here, who would have predicted this dip? Is there any theory, or are there any material in the world that could have predicted that this really happens with the solid state battery? So one good thing is, of course, with even these are really made by Donut Lab, all these tests for VTT. These are public data for future researchers that are doing work with solid-state batteries, and they can use this information and try to find out different ways of improve the battery life and efficiency and everything. But it's interesting. We don't know. And after when you go 100, 1,000, 10,000 cycles, maybe something really radical happens there. Who knows? You can't know it until you test it. So the claim about 100,000 cycles, it's strange, really strange claim. But now we also have to notice that all of this data, how useful this is, because it was made with damaged cell. So if the cell was new or if it was working properly, the data points would be very different, I guess. Okay, then there are some results in the table, and I will feed these these tables and data to my to my application and reflect it back to the other VTT reports and so forth. So I guess this is overlook for this report. Then I wanted to bring up two funny things. First of all, this podcast, I just noticed one interesting point. First of all, there is A1 McTurk, a doctor in battery science, who has been on some other shows also, but here he thinks to believe now that the battery is really a solid state battery. He does not see any reason not to believe. So, but apart from that, I found this very interesting allusion.
Us electrochemists could retire quite healthily, but this one has an interesting history. It seems to have attracted some very well-respected personnel from within the UK battery sector.
UK battery sector.
Right. Can't say too much at this point, other than I'm not involved with it. But
okay, can't say much about it, but he's not the one. But UK battery sector, I'm right away. I was thinking some people from McLaren, Hayden Wilson, and some third person that was also from McLaren, and they are working in Estonia and Finland in Donut Lab of Verge motorcycles. So when he refers to some respectful people in UK in battery business, connected, or how was it said? Let's listen it once more. We need to be careful with the
chemistry being advertised on popular science articles and so on. Us electrochemists could retire quite healthily, but this one has an interesting history. It seems to have attracted some very well-respected personnel from within the UK battery sector.
UK battery sector, yes. So maybe the McLaren persons are the ones he's referring, or some other private people. I don't know. But then later, I don't remember the part here, but I think there was even more connections. He started to speak about the importance of the battery being able to operate in high temperatures, and he was speaking about Formula 1 and some minor formulas also. So I think these things are seemingly were on his mind, Formula 1 and UK battery sector, and I can't resist but to think that he was referring to McLaren personnel, ex-McLaren of course, who are working now in Donut and Verge. And then one more thing before I close this one. I found these Verge Motorcycles USA small reel in YouTube that seem to say and point that they have 2026 Verge motorcycles in their store that has solid state batteries inside them. Let's see how it goes.
There's a lot of upgrades to the bike, and of course, they're going to ship with solid state batteries. So they're going to be lighter as well. So we went from a bike that was 540 pounds to a bike with the same battery capacity at somewhere around 487 pounds. That was a pretty big weight savings. We're looking.
Okay, so he's telling that he's looking the new bike here, and tells that there's the weight is not anymore as much as in the older model, and part of that must go to the lighter battery pack, or maybe the battery pack is same weight but holds more energy. I don't know exactly, but it's interesting that he points this bike and tells it's the new one, and it has the SB batteries inside it. What do you think?
Looking at a 2026 version of the new US Spike from Verge Motorcycles.
Yeah. Well, that's all, folks, for now.